Hello and welcome back to Global Climate Change. This is lecture 10. Today we're going to be learning about energy and emissions. So this is going to kind of begin our part that we can be using for our Green Ninja project. There's going to be some information in this lecture that you can actually use when you're coming up with your plan and you're figuring out how you're going to reduce emissions. So first of all, there is some reading here for this week. See, a little bit in chapter 8 and a little bit in chapter 9. Not too much, but it'll supplement, what I'm lecturing about today. So let's get started. All right, so first we'll be talking about energy and global warming. So for decades, energy generation in the U.S. has primarily relied on the burning of fossil fuels. Now we know that burning of fossil fuels is going to lead to CO2 emissions, and that is a greenhouse gas. So, burning of fossil fuels emits a greenhouse gas into the atmosphere and hence plays a role in climate change. In the coming decades, it's not only important to reduce the energy usage, but also look into alternative energy sources and electric power generation sources, because it's unrealistic for us to say we're going to, just stop using energy altogether. I mean, we do need to move around, we do need to produce food, there are certain things that we need to do. So not only do we need to reduce the energy, but we also need to figure out alternate ways of, having energy at the same time. So now there's actually three major fossil fuels. That's going to be coal, crude oil, which is like petroleum, and also natural gas. All right, so this is going to be basically a graph that's going to give you U.S. greenhouse gas emissions by type. So you can see that the total emissions are going to be 6,511 million metric tons of CO2. Carbon dioxide is going to be by far, the most, which is going to be at 81%. And, right after that is, well, not right after, but a long way actually after that is going to be methane at 10%. Okay, so this is actually U.S. electricity generation by source. You can see that 32.1 is actually going to be natural gas, and then almost 30% is going to be coal, and then that 20% is going to be nuclear. And the coal is obviously going to be a source of CO2. So, we really look at the coal. As far as how much CO2 is going to be released, as well as methane. Methane is produced or emitted during the production and transport of coal, natural gas, and oil. Is also a result of livestock and other agricultural processes. So that's where it's unrealistic to kind of get rid of methane altogether, because obviously we'll have livestock and we'll be transporting goods around still, but we still want to reduce them. Okay, so we're going to have here the electric generation USA. The 2017 largest energy sources for power generation, is at 32% natural gas, 30% coal, and 20% nuclear. But fossil fuels make up 63% of the power generation. That's going to be that natural gas and the coal combined. Where renewable resources make up 17%, which is actually up from 10%, that was in 2006. Okay, so, by contrast, we looked at this, which is going to be the USA electric generation by source. We're going to look at the California electricity generation by source. In California, it's 45.2% natural gas and 21 hydroelectric, where, coal is, I can't see because of the color. I think it says 5.9 on there. 9% being nuclear. So you can tell just by looking at the difference in these two graphs here, how much differently California treats its energy and its energy sources, which is good because we do have the highest population of, people within the state. Okay, so, again, natural gas is going to be 45%, hydroelectric 22%, solar is going to be 12%, where nuclear would be 9%. So there's definitely much, much less reliance, on coal in California than for the USA as a whole. where 46% of power generation comes from fossil fuels. Almost all is going to be natural gas, and 45% of electricity generation is going to come from renewable resources. One of the other things that I did want to mention was the Altamont Pass Wind Farm. This is a group of 4,930 wind turbines. Is the largest concentration of wind turbines in the world. It actually was commissioned in 1981, and it was installed after the 1970 energy crisis. So it's near Livermore. It's one of the oldest, or the earliest actually, wind farms that was formed, and it's right in our backyard. So me being new to California, I want to actually go check it out just to kind of see how, because they actually flash these like red lights when you come up to them when you're driving. I've kind of went over a bunch of them on the way to Vegas a few times. There's a bunch over there. So anyway, kind of cool stuff. Okay, so natural gas. This is mainly made of methane, and there's smaller amounts of other hydrocarbons. This can be extracted from oil wells, coal beds, deposits, and landfills. Burning is cleaner than the burning of coal or petroleum, but like coal and petroleum, it's a non-renewable resource, meaning it's actually limited. So we can't get, an unlimited supply. It's not... when I say there's a finite amount of it that we can have, and then after that it's all gone. So most natural gas is actually obtained by fracking. This is where chemicals are mixed with large quantities of water and sand and injected into wells at high pressure. Now the U.S. is actually shifting towards electricity generated by natural gas, so there is more fracking being done to retrieve that natural gas. Okay, so natural or residential energy use. This is combined with commercial usage. This makes up 12% of greenhouse gas emissions in the U.S. Almost half of the sector's emissions are due to space heating and cooling. So as my space heater is kind of going right now, that's the thing, that's actually going to, like, everybody having these space heaters, or even heating in their, their homes and air conditioning units and things like that. Combined, everybody using them, those are the things that's going to actually make up the most of the energy usage. And you can see here that space heating in 1993 made up 53%, where today, well, this isn't today, but in 2009, it was 41%. Where appliances are going to be 34%, and 24 in 1993. Air conditioning has actually gone up over time here, and you can see that water heating is actually kind of close to the same. So energy is actually going to equal power times time. So time is definitely an element of energy because it depends on how much of it we use over that time. So it's measured in watts, which would be a W, or kilowatts, which is kW. And 1,000 watts equals 1 kilowatt. So on your PG&E bill, the total energy usage is given in kilowatts. Okay, so what you do is you take that 1 kilowatt times 1 hour, and that's going to be basically how much energy is being used. Now, PG&E, I moved here, I don't know, about a year and a half ago. When I signed up for PG&E, I was kind of blown away at the way that they actually charge their customers, because this is something I was not used to being from Nebraska. So, there's this baseline amount that they figure the amount of energy intended to satisfy an average customer's electricity needs in a given area. So if you use the same as an average person, over the whole month, then it's, 13 cents per kilowatt. But if you go, to 101 or 130% of an average person, then the time that you use over 100% is going to be charged at 15 cents per kilowatt. And it kind of goes up from there. Here's kind of a little bit, I think of a little bit better. So basically, say your month starts here, and then your bill, your month ends here. Okay, and say you use what an average person would use up until about halfway through the month, then you'll pay that 15 cents for the half of the month. But then once you get over this tier 2 threshold, which is 101 to 130%, until you get to the 131%, you're actually going to be paying 18 cents. And it goes up from there. So what they're doing is incentivizing you to actually use what an average person uses and not go over that, because when you do go over that, then you're going to be paying more. Now, natural gas actually uses a two-year tier system. Um, in Nebraska, at least in Omaha, we had two bills actually. It would be one for power and then another one for gas, and they didn't have a tiered system. It's just everybody kind of paid the same. So I asked my friend actually to mail me one of her bills so I can kind of compare the two just to see the difference between them. Okay, so in 2017, average annual electricity consumption by residential customer in America is 10,000 and almost 400 kilowatts, with a daily average of 28. Now, Santa Clara County, which is where, well, I live in Santa Clara County, and if you live in San Jose, you live in Santa Clara County, then you're actually going to do 10 kilowatts less than the daily average. Now, what I'm assuming, the reason for that is because, I don't even have air conditioning in my apartment. I do use a space heater, when I get chilly, but only when I'm awake and, when I'm home and that kind of thing. Where I know when I lived in Nebraska, like right now, it's the high, I think today was like 32 degrees, which is freezing. So, and you have it on obviously at night when you're not home because you worry about your pipes freezing. I mean, if you go on vacation for like 10 days, and you're from one of those areas and it's during the winter, then you're actually going to keep your heat on because your pipes can freeze, and that is a lot of money to try and fix. So, I think that would probably be the reason. And as we're talking about home energy consumption, we should be going over these light bulbs. I'm older, so this is the light bulb that I actually was used to when I was younger, and this is what's called an incandescent light bulb. Those you can't even actually get anymore. This one on the left that has this like little squiggly thingy. This is going to be what's considered a CFL light bulb, and that's actually what I have in all of my fixtures here. And even better than that is going to be one of these, which is the LED light bulbs. So most incandescent light bulbs are 40 to 100 watts. CFL use about 75% less energy, and they last 5 to 10 times longer, where LED is 80 to 90% less energy and lasts 40 times longer. And like I said, you can't even get the incandescent bulbs anymore. They actually banned them because they take so much energy here. Once they're out, once they're done, then they're done. And I actually had a teacher when I was taking artificial intelligence, and he had some system in his home that actually would be ran by one box. It would turn on all the lights, like next to his bed or something. He could turn on all of his lights. And it controlled all of them, and the only type of bulb it would actually use is one of these incandescent bulbs. And so he asked every class, like who had these bulbs in their home, if he could somehow like confiscate them, because he like was dying because he wasn't able to get, these types of bulbs, and he wasn't able to control the lights within his whole house anymore. And so I'm assuming here soon he's probably going to be not able to control his lights anymore, because I doubt he'll be able to get a hold of them, for the, in a while at least. I don't know anybody who has any of these left. Okay, so this is actually a good point here where, we kind of go over direct and indirect energy, so you might, directly be able to say, I understand how much, energy a car actually, well, maybe not exactly how much, but you realize that, well, there's a lot of energy and there's a lot of like, fossil fuels that actually go into the car and power the car, and that car, has 86% direct energy. But there is indirect energy associated with it too, because it's manufactured. It's actually built somewhere, but like a computer, you don't always think about it as much, but, computer is going to, you plug it into your wall and it's going to use energy like that. But there's also a lot of energy associated with manufacturing that computer, and shipping it and moving it around and moving all the parts around, so that indirect energy, it's 83% as far as the computer goes. Now, obviously, there's going to be less energy, associated with the computer than the car, but it's that indirect energy that we don't always think of. Which actually brings us, to the Apple and the iPod here. Both items are roughly the same size and weight. They're both Apples. If you guys are too young, this is a iPod Nano. I don't even remember when those came out. Let's see. There's and it's associated with the apple, but we might not think about it like that because we have to water the tree. We have to have people pick the tree. We have to put fertilizers on it. Maybe we have to ship it around to wherever it's going. So it's definitely energy associated with that. But the Apple Nano, there's a lot associated with just manufacturing it. It's going to be, the parts are going to be shipped around, and it's going to be, moved from A to B. Interestingly, the energy required to make the device, the Apple Nano, is about 4 times greater than the energy required to operate the device over a 3-year lifetime. So we're talking about quite a bit of energy actually associated with just producing this Apple Nano. And if you think about the equivalent with your cell phone nowadays or anything like that, these they're only really built to last for a few years, so it's kind of a waste of energy to a certain extent. And you can see how it's one energy unit for the Apple versus 100 to 500 energy units for the Apple Nano here. Okay, so this is the transportation sector. You can see here that obviously the majority of transportation uses gasoline, but 22% does use diesel, with jet fuel being 12%, which, airplanes flying and things like that. You can also see that the different types of energy, so light trucks is 32%, with cars and motorcycles being 24. So, the majority of energy usage by transportation is going to be private use. We have semis being 23, 9% being aircraft, boats being 5, trains and buses being 3. Military is going to be 2%. So you can see here that a lot of the energy usage is actually going to be between light trucks and cars and motorcycles. Now, there's a lot of reasons to reduce energy usage, obviously, other than, climate change. So, reduce our use of fossil fuels, obviously, reduce greenhouse gas emissions, but also to improve air quality, pollution, and reduce our reliance on foreign oil because, we import a lot of the oil, and so, we're paying pretty high taxes on these things, and also to save money. You can see here that the top 5 oil importing countries in 2017, most of it is actually going to be the Canada. I'm sorry, because there's 3.5 millions of barrels per day that we import actually from Canada, with only 1 million barrel being from Saudi Arabia, some from Mexico. Okay, and then we also have the American Council for Energy Efficient Economy, and this releases an annual report that rank states by energy efficiency. They're ranked based on programs that aim to improve energy efficiency in homes, businesses, industries, and transportation. And you can see that we are actually number 2 here in California. Ironically, I have to look at my home state, and they're 44, which is probably not so good. But California here, we're doing really good, and we're trying, to be as energy efficient as possible. And here's some ideas to reduce residential energy usage. Along with the little segment I did on your PG&E bill, this as well is gonna, I would definitely want to say keep this in mind when you're looking at different ways that you yourself can reduce the amount of energy that you consume in your own home. So, wear layers to use less space heating, turn off lights when you leave a room, switch to environmentally friendly light bulbs, unplug extra refrigerator in the garage. My boyfriend and I actually, when I lived in Nebraska, it's obvious, like when I looked at that 44, being Nebraska, that number back here, I kind of was like, wow, that makes sense to me because, we had a refrigerator in our garage with drinks in it. We had a pool with a heater attached to it, just our own pool. It wasn't even like, an apartment pool or something, a shared pool. The air conditioning was set pretty cold, during the summer. There was only a couple people living in this large home. We could have definitely downsized into a smaller home. People drive large vehicles out there that take a lot of gasoline, for instance, as well. So, in other states, I think they're not as energy conscious as they are here. And so that kind of like the extra refrigerator in the garage kind of drove home for me, when I was reading about it. But substitute air conditioner with fan and open windows. Do understand though, that's feasible to a certain extent. If you live in Arizona or Nevada, I mean, it's like, what, 120 degrees sometimes during the summer there. And allow clothes to dry outside. I personally don't have anywhere I could even do that. So, it's all about you and where you live and what you can do yourself to actually feasibly reduce the amount of energy that you're using. And then, there's renewable energy sources for electricity. So about 20% of global electricity generation comes from renewable sources. And this amount varies greatly on country. We have 17% here in the United States, with Norway being 97%. And by 2030, 25 to 50% of power generation should be from renewable energy resources or sources worldwide, and that is going to allow our carbon footprint to go down so that our CO2 levels, in the atmosphere can go down, and greenhouse gases, obviously, will start to dissipate, and then, hopefully we won't be warming as much as we project at this point. Okay, so this is everything that I have on this lecture right here. I will be uploading a second lecture on the, what do you call it, the Green Ninja Project. So look out for that. We will not be having a discussion this time because you guys should be doing things to get ready for that Green Ninja Project. I'm going to try to keep the homework kind of light so that you guys can work on that Green Ninja Project and think of ideas to reduce your own emissions within your own home and your own energy usage. So I hope you guys have a great week, and thank you.